Hello and welcome to Edpuzzle 2.2. So today we are going to learn how to graph log functions. So for number 1, it says construct a table of values and a graph for each of the following functions. Be sure to select at least 2 values on the interval x is between 0 and 1. So how do you graph a log function? How do you choose what values to pick? A lot going on here, right? So how I would recommend doing this is I personally would like to change this into an exponential. Now, we know that exponentials are the inverse of logs, so what we can do is find the points of the exponential function and then just switch the x and the y values. So for this guy, if I rewrote this as an exponential function, it would be y equals log 2 of x, and then I would say 2 to the y, 2 to the power of y equals x, right? So we could go ahead and construct a graph, right? Let's think about it first as if this was an exponential function. I'll put this graph up here. So we'll say 2 to the x equals y, right? And we can plug in -2, -1, 0, 1, and 2. So if we plug in -2, we would get 2 to the -2, which would give us 1 over 2 to the 2, which equals 1/4. If we plug in 2 to the -1, we get 1 over 2. Plug in 2 to the 0, we get 1. 2 to the first is 2. 2 to the second is 4. And I'll even put in a few more. We can do 2 to the third, which is 8, and 2 to the fourth, which is 16. All right, so these are the values if this was an exponential. So now what we can do is we can write this as a log function. So how do we write as a log function? You just switch the x and the y values. So you've got 1/4, 1/2, 1, 2, 4, 8, and 16. And then we'll plug in -2, -1, 0, 1, 2, 3, and 4. All right, so I took the inverse of this guy, which would be that, found the points, and then I just swapped them back to make it a log function. So we do 1/4, -2, 1/2, -1, 1, 0, 2, 1, 4, 2, 8, 3, and then 16, 4. So that is what our function would look like. So now let's go ahead and try it for the next guy. I'm going to go ahead and make these smaller because they're quite large. All right, so let's try it for log base 3 of x. So let's go ahead and do the same thing. We're going to turn this into an we'll write this log as an exponential, right? So it would have been y equals log base 3 of x. It ended up being 3 to the y equals x. So then for the inverse, that would be 3 to the x equals y, right? You swap the x and the y values. So let's find points on our inverse function, which would be 3 to the power of x. We can plug in -2, -1, 0, 1, and 2. So if we plug in -2, 3 to the -2 is going to be 1 over 9. 3 to the -1 is going to be 1 over 3. 3 to the power of 0, 1. 3 to the power of 1 is 3, and 3 to the power of 2 is 9. So those are the points on our exponential graph. Now we have to make our log graph. Remember, these are inverses, so all we have to do is swap the x and the y values. So we get 1/9, 1/3, 1, 3, and 9. And then we've got -2, -1, 0, 1, and 2. So let's go ahead and graph. We get 1/9 and -2. 1/3 and -1, 1 and 0, 3 and 1, and 9, 2. So we can go ahead and graph this one. Looks like that. All right, let's try the next graph. So this guy written would be log base 4 of x. If I wanted to write him as an exponent, it would be 4 to the power of y equals x. So then our inverse function would be 4 to the power of x equals y, right? You swap the x and the y values. So now let's go ahead and find some points on our inverse graph. 4 to the x. We'll do -2, -1, 0, 1, and 2. So 4 to the -2 power, negative second power is going to equal 1/16. 4 to the -1 is 1/4. 4 to the 0 is 1. 4 to the first is 4, and 4 squared is 16. Then we plug these in, or we don't plug them in. Now we need to swap the x and the y values. So we get 1/16, 1/4, 1, 4, and 16. -2, -1, 0, 1, and 2. Now we plot them. -1/16 and -2, -1/4, -1, 1, 0, 4, 1, and 16, 2. All right. Got another one. Let's go ahead. We'll rewrite this. Oop, I don't know what's wrong with my pen. There we go. And then if we were to rewrite this in exponential form, we get 10 to the power of y equals x. So then the inverse of that guy would be 10 to the power of x equals y. Let's come up with our charts. So we'll plug in -2, -1, 0, 1. We'll put 2, but we won't be able to graph it. So then 10 to the -2 is going to give us 1/100. 10 to the -1 is 1/10. 10 to the 0 is 1. 10 to the first is 10. And 10 to the second power is 100. So then we'll go ahead and make our chart here for our log function, right? You just swap the x and the y values. 1/100th, 1/10th, 1, 10, and 100. So we've got -2, -1, 0, 1, and 2. So we'll attempt to plot 1/100th. So very close to the y-axis there, but not touching. And then we got 1/10 and -1, 1 and 0, 10, comma 1. And then we can't plot this last point. That's 100, comma 2. So that's way off the chart. So these are pretty much the most points we can plot. It's going to look like that. So it says, how did you decide what values to use for x in your table? So what you can say is that you found points using the inverse. We found points using the inverse function, then swapped the x and y values. All right, so for number 4, it says, what similarities do you see in the graphs? So there should be a lot of similarities here. So first, you could just see that all the shape of these graphs are very similar. This is called like the logarithmic curve. So you could just even say, you know, they all kind of have the same shape. All right. One one thing, they all have what's called an asymptote. All right, and if you look, right, they all have an asymptote here. The x values do not go beyond here. So you could say that there's an asymptote at x equals 0. And you can also say that their domain is greater than 0, right? We didn't get any x values that are less than 0 here. Not there, not there, not there, and not there. All of the x values are bigger than 0. And then another thing you can say is that all of these graphs had the point 1, 0, right? We had 1, 0, oops, 1, 0, 1, 0, and 1, 0. So you could say contains the point 1, 0. All right. Then it says, what differences do you observe in the graphs? So essentially, the bigger this base is, that's going to impact the shape of the curve. Okay, so you could just say the base changes. You could just say how fast it grows. All right, so I'm not going to finish the task in this